In this lesson, we'll explore the OptiRough toolpath as an efficient way of removing a lot of material so we can work towards finishing this part. I'm going to go back to isometric and I'm going to fit it to my screen. And under the 3D group, I'm going to go right to OptiRough. So when OptiRough comes up, it wants us to choose our machining geometry and our avoidance geometry. For the machining geometry, I'm going to simply triple click, and as you can see on our prompt here, triple click to select the solid body. And that's what I'm going to do here. So triple click, the body is selected, and as you can see, it extracts out the entities, and in this case it sees 112 entities, most likely surfaces that it'll be machining. Under the avoidance geometry, there's a few different things I can do here. In this case, I'm going to select entities, and I'm going to choose the surfaces that we created previously in other lessons as avoidance geometry. Since I don't see them here, I'm going to go to the Levels tab, turn on Surfaces, and then I could say either all orange, or since there's only 7 of them, I could manually select these surfaces right now. And when I'm done, I hit End Selection, but before I hit End Selection, I'm just going to turn off that level again. And as you can see, avoidance 7. I'm going to stay away from the avoidance geometry by 0, and I'm going to stay away from machining geometry by 50 thousandths because I'm going to come back later on and finish these off. I mentioned we didn't have to choose avoidance geometry because we have other options that you'll see later on. For now, just realize we're avoiding the surfaces that we created, and we created those previously specifically so we could select those and use them as avoidance regions. Because that way the tool's not going to work its way in here and work its way in these areas. Under the toolpath control, I'm going to choose a boundary chain. I'm going to select one, and in this case, it's on level 10 that we created previously, called wireframe. And notice it's not letting me select it because our chaining is currently set to solid, so let's go back to wireframe, and we can select it. And then we'll turn it off. So there's our one boundary chain. So this option here, skip pockets, we can choose skip pockets and tell it to skip all, and it will avoid many of these pockets. So the combination of skip pockets and those surfaces that we created to restrict the tool from going into those areas, between the two of these, we're going to have a pretty efficient toolpath here. We can also choose how we're going to respect the containment boundary. We're going to come in from the outside, and we're going to compensate to the center. Under the tool, I'm going to choose this 1/2" chatter-free ISCAR tool, and we're going to call this OptiRough. And again, this comes out in our G code, so it's very easy to find the section of the code if you're looking for that OptiRough toolpath. Now, since this is an ISCAR tool, I can turn on ISCAR HEM, and this gives us the ability of using the data within the tool to have a very fine-tuned feed versus speed scenario. So in this case, I can change this HEM factor, let's just say to 1.5, and everything adjusts accordingly. You'll also notice that you have restrictions on what step over you can choose. So if we just jump down here for a minute to cut parameters, you'll notice that my step over can either be 5, 7, or 10%. And that's specifically because we have the HEM factor turned on. So let's take a look at the cut parameters here. Our step over will be 10%. Our step down, since this is an ISCAR tool and since we're using a dynamic toolpath, we're going to do a step down of about 150%. However, we're also going to do a step up. So we're going to do a very large step down. It's going to work its way in towards the center, and then it's going to do smaller incremental step ups. I'm going to mill vertical walls here because we do have a bunch of vertical walls here. And incidentally, we could have created a separate contour toolpath that would just hog out most of this material on the outside. But this toolpath is effectively doing that as well. So we have many options here as to how we would machine this. And under the steep shallow, I'm going to choose a couple of depths to restrict the minimum and the maximum depth. For example, the maximum depth, if you notice, if I go to Z coordinate of point, we don't want to machine down into our fixture here. So I'm going to select this as the maximum value. And as you can see, that's minus 2.5. So just to be safe, let's say we're going to go down to a maximum depth of minus 2.5. In the minimum depth, if you recall, we already faced off the top of this part. And this face is perfectly flat now. So if we select this value, and you see it's at 0.07, let's just say the minimum depth is minus 0.08. So it's actually not even going to machine this flat face. It's going to start slightly below it. And under linking parameters, let's adjust our retract, and we'll make this a minimum distance. However, I'm going to output a feed move here, and this is safe. Depending on some of your machines, you may want to do this as it may not know how to handle that retract. Let's click OK, and this will be a good time to explore the multi-threading manager. So as you can see, this toolpath is currently processing. If I go to my toolpaths tab, you can see here it's processing. So this is a good way of identifying that you can right click and actually pause or stop some of the calculations. I'm just going to click OK and let it continue while I set this up. And you'll see that this will eventually finish up and the toolpath will be created. So now that it's done, let's select on the toolpath and see what we got. So we can see our depth cuts, and that's 150% the tool diameter. And then we can see our step ups, and in this case it's milling the vertical walls. You can also see that we're not machining this top face because we selected the depth and we said go slightly below it. And you can see here we're machining into some of these areas, but because of the containment region, the avoidance regions, and our option to skip pockets, it's not going into some of these pockets like you might expect in the past. So this looks like a really good toolpath. One thing I encourage you to do if you're exploring is to take the toolpath and copy it. Copy it afterwards and go in there and just adjust one setting. So as an example, let's go into this copied toolpath and just change one or two settings and then recalculate. So down under this copied toolpath, let's go into the toolpath control and turn off skip pockets. And let's recalculate this. And as you can see with this calculated toolpath, this is the new one we just created. And if we go back to the old one, you can see that we have less tool motion here. So just this minor exercise right here is a good way of looking at the differences of these toolpaths and how they are impacted by settings inside of the toolpath. For now, I'm going to right click and delete this just so we're not confused with it. And to recap, we have our stock model here, and then we have our OptiRough. So let's create another stock model after this OptiRough so we can really see what this stock is going to start to look like. So let's go into stock model. And again, we have 1, 2, and 3, which is after drilling. So this one will be 4 after OptiRough. And the initial stock place would be 3 after drilling. And the source operation will be the OptiRough. Let's click OK. And we can really see how this part will start evolving into its final shape. And as you can see here, you can see the step-ups of that slanted set of surfaces there. And you can see the areas that we did not go into based on the skip pockets. And of course, we didn't go into this area because we capped it off with a surface, and we previously already machined this. In the next lesson, we'll explore the OptiRest toolpath so we can use that same toolpath technology and really clean up this model.